My name is Honza Koudelka, and I'm from 2 4U Software. 2 4U is a company based in Prague, Czech Republic. We do FileMaker development, FileMaker plugins, for which we are the most known in the world. Then scripting editions, mobile apps, web apps, and also some electronic products like e-books. Today I would like to talk and discuss two topics with you. One is optimization and one is troubleshooting, because a few years ago we created a product called FM Bench, which helps FileMaker developers optimize speed of their solutions. And last year or this year suddenly discovered that there is one more thing that FM Bench gives us without intention, and that it helps us with troubleshooting our solutions. Although I know this is pulse and error, so it should be more technical. I hope you're tuned to that mode. So I expect to spend most time showing something on a screen or discussing details of the topics with you, as I expect you to have some great ideas and questions, so hopefully we'll do. Let me start with the first topic, and that's optimization. And before I dive into the details, recently, just before going to FileMaker DevCon, I read this story online about a New York City restaurant that had problem with customers complaining that their service has significantly dropped in quality over the last 10 years. Have you read that story?
Yeah, a couple have. It turned out to be all about how people are texting and rather than talking to the waiter, as I sit here using my phone.
Yes, exactly. That's a short story. Actually, the problem that they wanted to resolve was the complaints of the customers. So they hired an agency to actually answer the question what has changed and how and why the quality of their service dropped over the 10 years. And the agency that they hired suggested that they use a camera, the CCTV recordings, to compare how their behavior changed. And luckily they discovered that 10 years ago, back in 2004, they replaced the CCTV that was originally using VHS with a digital one, and they found the VHS tapes in the stock still in the recorders, so they could compare exactly the same picture 10 years ago and now. And as you already noted, the thing that they discovered was that the service was still the same. They actually measured time between events like ordering food and bringing the food, and the speed of the service was to a minute exactly the same as 10 years ago. But what was changed was the customer behavior. The nice thing in this story is that if you want to know what has changed or what's being slow or what is that thing that you need to change or optimize or improve, you first have to somehow audit that thing that you want to optimize, whether it's process, whether it's software, it doesn't matter what it is. You first have to audit it. You first have to have exact records, because if you just base your decisions on feelings, the problem is that the feelings may be wrong, and you may be judging wrong and focusing your efforts on the wrong thing. So even before knowing this story, it's now 5 years ago, I discovered that the best and the most efficient way to optimize things is to start with the auditing, then identifying a bottleneck, and then optimizing the bottleneck. And actually defining the bottleneck is something that I learned long time ago in a company, in a manufacturing company where I worked for, during a course of just-in-time technology, during which we learned about optimizing production lines in factories. And a few years ago, when I was trying to make our FileMaker solution faster, I recalled that I actually learned something about optimizations back in this factory. And so I tried to apply it to software and discovered that it works. That it's a universal process you can apply to anything that needs to be optimized. You can think about a process like about a chain. Who knows how strong is a chain?
So the strongest is weakest.
Exactly. And the same is with software. So if you have a solution that's perceived as slow, it's only as slow as the slowest part of it. And it's hard to say what's the slowest part, but what we do with FMBench, that's the tool that we created after discovering that this is the right way to optimize a solution, is that we measure everything. We start with scripts and we measure every single script in a solution to find out what time the solution spends over a specific period in each script. So if you run a script that takes 10 minutes to run, but you run it once a day, but you have another script that takes just 2 seconds, but you run it a million times a day, then the 2-second script is that bottleneck, not the 10-minute script. And by measuring everything, you get this accurately, and you accurately identify the bottleneck. And once you have identified the bottleneck and optimize it, you can repeat the same process, because once you optimize your solution or process or whatever, you get to a point when you can apply the same process again, because once you remove the bottleneck, something else becomes the bottleneck. Of course, the solution is already much faster than it was before, but you can make it even faster. And that's why I say that you can apply optimizations endlessly. You can optimize an already optimized solution. The only point is whether it still needs to be optimized. But the question whether it can be optimized can be answered very quickly. Yes, it can be. Everything can be optimized, and it's only a matter of whether it needs to be optimized and whether the cost of optimizing it is worth the improvement that you can achieve. But in the process of optimization, there is something that makes it a little bit harder, because the process seems very simple. But when you find the bottleneck and you have to optimize it, you can discover that you cannot optimize it. You don't have enough skills or tools or whatever. And specifically in FileMaker development, I discovered that applying the same process recursively inside the process is the answer. So in a FileMaker solution, we start by finding a specific script that's bottleneck of the solution, and to optimize that script, we look for a bottleneck inside that script. Can you imagine how we do that?
Stare at the server audit log? Smell fluid?
the same process. So we audit the script in detail. We benchmark every single script step. In order to be able to do this, we added the exact timestamping feature in one of our plugins. So we measure timestamps with microsecond precision, and this lets us measure how long it takes to run a specific script step, even if it's very fast one. So the next step we do is we measure every single script step in the script, and that way we find what's the bottleneck of the script. And then we can apply the same process again. The only problem is that it becomes even a little bit more complicated. For example, if the bottleneck of the script is a script step that involves a calculation, we can benchmark the calculation. If it's based on a custom function, we can split the custom function to multiple parts and benchmark each part, and then discover which part of the custom function is the bottleneck of the custom function. However, there are other cases where it's not so easy. For example, in one case when we were optimizing our solution, the slowest part of the script was a set field script step with that was not using a calculation but just putting constant, I think it was 1 or 0, into a field, and this script step was taking 5 seconds. So then we applied another method, and that is I call it binary corrupting FileMaker file. So we make a copy of the solution and deleted half of everything from that solution to find out whether it becomes faster or not. So this way we can easily find out that if it becomes faster, then the problem is somewhere in the half that we deleted. If the solution doesn't become faster, then we keep deleting the rest of the solution. And this way we, in the case that I mentioned, we actually found that the slowest part of the solution was a relationship that was based on the greater than predicate. And that was the way to optimize it. So now we only had to find an alternative way to achieve the same result without using this relationship. So this is basically the process that we apply to optimizations. And now I will turn off the slide and I will show you example on one solution where we applied it. And by the way, without intention, I will also reveal something that may be a bug in FileMaker 13, so we can then talk about it later as a side discussion. So this is a solution that we built for our customers. As I mentioned, we also do mobile apps and electronic books. So we have customers for which we publish books on the iBook store and make App Store and App Store. And this app is designed to download the sales stats from Apple and to present them to the client with some calculations and calculating provisions and things like that. The problem with this solution that we had was when it downloads the data from our server and extracts it to the database, it takes very long time. I was using the Simpsons family to demonstrate a few things with this on FileMaker DevCon. So I used Bart's character to demonstrate someone who needs the solution faster. And here I have the 4 steps of the optimization. So as I mentioned, the first thing that we do in the optimization process is auditing the solution. and we do it through FMBench, our product. So I'll show you what we discovered in FMBench after using the solution. So here I'll process the So this tool called Bottleneck Finder exactly measures how much time was spent in each script of the solution, and it emphasized that script that took the most time. As you can see, we spent 17 seconds just in the script extract sales data, and this script actually took 51% of all the time spent in all scripts in the solution. So this way we discovered that this is the script that we need to examine, and I will now show you that script. And this is the bug that I told you about. I will get back to it later. So here is the extract sales data script. As you can see, we have FMBench benchmarking at the beginning of the script and at the end of the script. And in order to get more data, we added a few script steps here to benchmark the scripts itself. As you can see, there is a loop, so I added a benchmark to show the start of the loop, then each iteration of the loop to find out whether there is one iteration that's taking longer than the other ones, and then we measure another point at the end. And when we collected this data, it was actually running on FileMaker Go on iPad. So when I got the data from the iPad and recorded another session, here I got the detailed measurement of the script, so I could see that an average iteration of the loop took somewhere between 2 and 4 tenths of a second. So the real bottleneck needs to be somewhere inside the loop. Are you following me?
Yeah, that's cool.
Great. Okay, so this was the third step, when in the sales data, just a minute. Okay, the sales data extraction loop actually uses a few custom functions called unpack number, unpack text, and so I measured these custom functions in detail. So by inserting the FMBench measurement points in the custom function, I could measure the custom function itself. The discovery that I got was that the custom function unpack text was the slowest portion of the solution. And the unpack text, and the unpack text here in the original file was using a function called UTF-8 a hex to text custom function, which is this one. The custom function is a recursive custom function that actually does the UTF-8 hexadecimal text encoded conversion to regular text, and it I discovered by measuring it that it's very slow. So I thought that optimizing this custom function would be the way to go, and I built this new version of the custom function which utilizes global variables to avoid passing too long parameters to the during the recursion, and measured it again and discovered that in this case the custom function was a little bit faster, but it was not the right thing. And why I'm saying that is that even when you follow the process and find the bottleneck and optimize the bottleneck, that may not be the right way to do it. Sorry, I'll show you all the sessions at once. And here you can see that by optimizing this custom function, I got from 17 seconds to about 15 seconds. That's definitely not something I was looking for. I was hoping for speeding it up at least 5 or 10 times. So I thought of different ways, and that's when what's called out-of-the-box thinking is very important, and sometimes you have to come up with an alternative solution that's being designed from completely different angle. So I thought of simply removing that UTF-8 encoding from the text that is transferred from our server and just transferring the plain text. And the actual optimization of the custom function was not using it at all. So in the new version of the solution, the unpacked text is simply returning the text as it came. Because originally I used the conversion to UTF-8 and I thought it was a good idea for the transfer using the insert from URL and to avoid some problems with weird characters and so on. But this way I discovered that it's better to simply not encode the text and just make sure to remove all weird characters on the server before transferring the data, because especially on iPad this takes ages to unpack from the UTF-8. And as you can see in the bottleneck finder here, after removing the UTF-8 conversion, the script runs only less than 2 seconds instead of 17. So that's the result that I wanted to achieve. So back to the process for optimizing a solution. The important thing here is that when you get the bottleneck and you identify what needs to be optimized, you really focus on that thing, because like in the chain, if you have the weakest link, there is no sense in replacing any other link if you want to make the chain stronger. Until you replace the weakest link, the chain will be still the same, exactly weak as it was from the beginning. And that's one of the biggest mistakes that we were doing for maybe 8 years in 2.4u when trying to make our solution faster. We were optimizing scripts that were not the bottlenecks, and we were surprised why all the effort leads to almost no change of the speed of the whole solution. So the biggest mistake you can do when optimizing something is focusing your effort on something else than the bottleneck. If you identify the bottleneck, you have to trust if you use a good, accurate system to audit the system that you want to optimize and identify the bottleneck, you have to trust that this is the bottleneck and that's your only focus for optimizing. And when you try to optimize it, the next biggest mistake you can do is give up. When I started applying this process on our solution, I asked one of our team members to find the bottleneck in our system and optimize it. What he did is that he found the bottleneck. He used FMBench to find the bottleneck in the solution. He identified the specific script to optimize. Then he took that script to optimize, looked at it, and selected a few script steps that he knew how to optimize them. He optimized those few script steps, and suddenly the script became even slower because he didn't apply the same process inside the script, and he didn't identify the bottleneck inside the script. When he did that, he discovered the bottleneck is a script step that he didn't know how to optimize. So again, he did the same mistake and jumped to the second slowest part of the script and tried to optimize it. And the solution was still slow and the script was still slow until he really thought about that single script step that was identified as the bottleneck. And when he did that, he made the script run about 1,000 times faster. So if you avoid these two mistakes, work focusing on something that's not the bottleneck and giving up on optimizing the bottleneck, then I guarantee that you will succeed. And if you get stuck with optimizing specific thing like specific script step or script, you can turn to us for help because we have done it many times already. Just recently, a customer came to me asking if we can help him optimize a script in his solution. So we applied our principles on his script, which was originally running about 20 seconds, and we cut it down to 5 seconds. So he is happy, and we have another experience with optimization. But now back to my mistakes, because I keep doing a lot of mistakes, and that's very expensive and hard way to learn things. Can you guess what was my next mistake I did?
Didn't repeat?
I did repeat it, but what was again surprising was that the value that I was getting from the optimizations was not what I expected. And the mistake I was making is that I was assuming that time, a value of time, is the same regardless of conditions. But the truth is that it's not the same value of time. If you optimize a process, or if you optimize a solution that runs at specific speed, what you happen to optimize is a process that's known, that's often repeated, and that's expectable. So if you optimize a process that originally took 2 hours and you optimize it to take just 20 minutes, then when you apply that process, it takes 20 minutes every time. But if you didn't optimize it, you would expect the process to take 2 hours. And you would count with that when selling your services to customer. So if this process is expected to take 2 hours, you will try to sell 2 hours of your work. Is that right?
Yeah, I can see that.
So if there is a known process and it's known how long it takes, it's a time whose value and cost is predictable. But I suddenly discovered that there is a time that's significantly much more expensive, and that's unscheduled time, interruptions. Do you agree?
Yes. Yeah.
Because when you don't expect it, you don't make advanced effort to sell the time. So when something happens, when you have problems and troubleshoot a solution, when you try to find bugs that stop your customer or stop your users from working, and you have to interrupt your regular work, it's very hard to evaluate the time and effort you spent to fix the problem. And this way I discovered that the optimizations that we were making are valuable, but what will be much more valuable is cutting the time that we spent on troubleshooting. And I discovered that I already have a tool for it, because when trying to optimize our solutions, we installed and started using FMBench in every solution that we make. In our own system that we use internally in 2.4u, we keep it on all the time. So every user, when using our system, is audited, and we keep the log of everything that's being recorded. And when a user comes, when a user comes to us saying that there is something not working in the system, we have much better data to resolve the problem. So we don't end up doing inefficient troubleshooting, which is when we ask the user what happened, then we try to reproduce it, and then fail to reproduce it, then come back to the user and repeat it. This is the inefficient way to do troubleshooting. Are you familiar with that?
Mm-hmm. Yeah. It's the only way I do
it. Well, before we had FMBench, very usual way to troubleshoot issues in our system was that we got a call, then we spent like between half an hour and an hour to reproduce the problem on the test copy of the system. And after spending that 1 hour, we usually spent like 5 or 10 minutes fixing the problem. Does that sound familiar? Yeah. Can you estimate what's your typical percentage of bug hunting, as I call it, and bug fixing?
It seems about right. Yeah, it's about the same. 4 to 1, 10 to 1, somewhere in that range. Yeah, totally.
Yeah, so it's similar for everyone. And the biggest problem here is when you get a user who cannot explain how they got to the bug.
Exactly.
And that's really common. That's not unusual, right? Yeah, I recall we have one very talented user in this matter, who who always calls that something doesn't work, and he says it gives me an error message, and now I got this invoice screwed up. And I ask, what was the error message? I don't know, I didn't read it. And what did you do before this happened? I don't know, I just wanted to create an invoice. And that's a typical answer. And so we try to identify what the user did, try to repeat his steps on a test solution, and we don't notice the error. So we have to repeat the same process again. The user thinks that we are absolutely stupid because he well explained what happened, and it takes us ages to actually discover what happened in his case. So a better way is to make this reproducing much faster. And if we have FMBench installed, and if FMBench logs every script running, and we always run a script when pressing a button in the system, we never use script steps directly from buttons. Do you do the same thing?
What was that again? What now?
Well, when you add a button to a solution, do you always have it attached to a script, or do you sometimes use the direct script step action, like such as go to layout and things like that?
Always a script for me, except for a few.
Almost always.
Yeah.
Normally a script.
Yeah. Well, there is one more benefit of doing a script, and that's when you want to change a behavior of a button that you copied to 50 different layouts. If you use a script, you can just change the script, but if you have it direct, you have to go to all the 50 layouts and modify the button. But the benefit we have with FMBench is that every time a user presses a button, we get a log record. Every time a script ends, we get a log record. Every time a script calls a subscript, we get a log record. So we even have a chain of all subscripts. So if there is a script that should run only under certain condition, we know from the log whether it was executed or not. We also have the script parameters and script results if we need them. So when a user calls, hey, I have a problem, this invoice is screwed up, I ask him for an invoice number and when exactly the problem happened, and that's all I need. Then I look in the log, I see what the user was doing, I see what was happening inside the solution, and I can just follow the log and exactly reproduce the same process the user was going through. And almost in like 90% cases, we don't have to repeat because we succeed at the first attempt to reproduce the problem. And in these cases, the ratio between reproducing and fixing the bug is reversed. We usually spend 1/4 of time that we spent on fixing the bug trying to reproduce it. And that's a huge time saver for us. And because we do have to work with problems, issues, and troubleshooting bugs, this single benefit is saving us more time per year and more value than the optimizations. And it's unintentional. It's just the extra benefit of FMBench that we originally created for optimizing solutions. So let me show you very briefly in the same sample solution how this works. I use a different sample character, that's Lisa, as a sample average user, and let's imagine the average user reports that after switching tab here to a month view, going to summary and going back to the home screen, she doesn't stay on the month tab, but she's switched to the day tab, which she doesn't like. Well, after describing this behavior, it's very hard to reproduce a problem. You can switch tabs here, go to summary, go to back, and it still stays where it's supposed to stay. It's still month, a week, it's still month. So it's very hard to reproduce problem. But when you have a log, you can just see what the user was doing and follow the same process. So here I select the Lisa session. I go to another part of FMBench, which is called Session Browser. So this is the session in detail. And when I zoom even more, this go to setting is the key step that we didn't try. So I switch back to the solution, go to summary, go to settings, go back and back home, and now I'm on the day tab. Let's try again with the year, summary, settings, back, and I'm on the day tab. So by examining the session in FMBench, I knew exactly what the user was doing, was able to follow the same steps, and immediately reproduce the problem. Now I can open the script debugger and see what is happening. And in this case, what was happening is that from the old days of this solution, we had a script step in go to settings. Here, in go to settings, and we had a script step that was calling a script remember dashboard tab. But when this script is called from a wrong context, it doesn't remember the current tab correctly. Later we replaced this with a script trigger on layout exit. So when we exit the home layout, we remember the dashboard tab. But in the case of going to the settings from the summary layout, this was overriding the remembered tab, and that was the bug. So by following the script, by following the process based on the log, we were able to reproduce the problem, find the bug, and fix it by simply deleting this obsolete script step. So when I get back to the troubleshooting process, if you have the log to examine, you can very reliably reproduce the process that the user was going through and fix the problem. So again, back to the potential mistakes you can make, and again, I admit that we do them. We made them many times. If you try to, if you are supposed to reproduce the problem, you have to reproduce the problem before trying to fix it. There are things that you can fix immediately, of course, but if you don't get to the solution within like 5 minutes, it's very important that you don't omit this second step. If you don't reproduce a problem, you can end up spending hours trying to find where the problem is without actually knowing what was happening. So one of the biggest mistakes you can make when troubleshooting solutions is forgetting to reproduce the user's problem. When you do want to fix the problem, one very common mistake is trusting the user too much. Sometimes users claim that this is how the solution should behave, but you have to make sure that you talk to the right user who is really competent to say what is the correct behavior. Otherwise, user asking for something to be fixed can actually convince you to break it. Another problem we have very often, is breaking something else. And here, the best advice I can give you is use the tools that are available, such as we just like we use FMBench for keeping the log, we use base elements and sometimes inspector to examine all possible relationships between things in FileMaker solutions, and not only data relationships, but related scripts, related layouts, things like that, because very often one field or one script is used for multiple things, and when you change its behavior you can fix one thing and break two other things. So it's very important before changing existing behavior you examine what other things may be affected as well. And we find base elements and inspector very effective in this, so I recommend you use them, because it's again just like keeping the log of what's happening in the solution. They can save you a huge amount of time. And last but not least, it's very important to report when the bug is fixed. This is something this is the mistake we do most often. We fix the bug and we forget to tell the user that it was fixed. And then the user comes back to us reporting the same bug again. And we become nervous because we start thinking that we didn't fix it properly, and the fact is that the user just didn't know about the bug being fixed, and he didn't test it, he didn't try it again, he just wanted to bring it to our attention to fix it. So when the user doesn't know the bug was fixed, you can easily get a new report of the same bug from the user, although the problem has already disappeared. So that's basically what I had to present, and it seems we have about 20 minutes for discussing anything and diving deeper with your questions. What do you think about that troubleshooting value? It was actually a very surprising discovery for me, and I have to admit that it wasn't me who discovered this, but my client pointed me to this fact that the value we are getting from the ability to troubleshoot our solution is much higher than the value we are getting from the optimization.
That's cool.
Yeah, that makes sense. I haven't logged things to that level of detail before. To be able to know and to be able to actually reproduce exactly what a customer's doing, that's very nice. Usually I only log like really important things, but not like, navigation.
Yeah.
But I see the value in it now for reproducing.
I have a question. Did you want to ask your question?
But go along this vein.
Okay. I've done some similar stuff, although not in its own tool. So I'm excited at the idea of having to not rebuild it from scratch in every solution. So I like thanks for making this tool, first of all. I am wondering if you would consider adding some functionality that might integrate what one can learn from the server logs, because I've found that a lot of the bottlenecks I've found, like probably half of them, are not somebody running a script, but somebody doing something like doing an unindexed find.
Mm-hmm.
They're going to do that and slowing everybody else down, and then everybody else says, it's slow. And then, so it's been very useful though to then be able to go back and say, okay, at this time, who was hogging traffic?
Right.
And so it's been very useful to say, okay, it seems like 50 times a day I see this, 1,000 kilobytes or something going across the network. What is that? And then I can compare it to the scripts that have been recorded as you described.
I understand. Well, actually, you're not the first asking about this, and we are considering some ways how to add this as a feature of the next version of FMBench. Actually, having a different kind of view, instead of focusing on a specific user session, focus on a specific time frame. and finding some relationship between one user's activities and other users' speed, etc.
It's also useful to know that like this script usually runs in 2 seconds, but sometimes it takes 15 seconds.
Right.
Yeah.
And see those anomalies and then trace back
But you
why
can
that's happening.
Oh yeah,
I mean, you can't do it back to the server, but the tool, the bench tool, does allow you to go and see how, you can go look at every time that script ran and how long it took.
But to be able to A and B that,
Yes.
Yeah,
on the
the
left
A and
side,
B is the
yeah, you see on the left side,
Exactly.
we just saw, and on the right side, the server log. Oh my god,
That would be huge.
Yeah. Because I've sometimes imported the server log into the solution, and I'm sort of trying to match them up, but I don't want to. I don't want to do that myself. I would love it if you did that.
Well, the good thing is that if we have FMBench implemented properly in every script, we already have the data, and this is just a new way how to visualize the data that we have. And actually, part of it is already available because in Bottleneck Finder we have the individual scripts, and when you expand one script, you see all its instances. So you can and they are sorted by time. So they can be sorted by time. So you can see that like the script was run 100 times. In most cases, the average time was like 5 seconds, but once it took 20 seconds. So you can examine that specific instance of the script and see when it was happening. And as you said, when we have some nice view of what was happening at the same time on the other users' sessions, then this would help us a lot to find out how one user is affecting speed of other users.
So if you have like 10, 20 users on a network, how does this thing work? Do you analyze every single user on the network and what they're doing? If they're all running similar scripts. Like I have companies at 4 o'clock, they have to all turn everything into invoices. So they run these scripts that create 300 invoices, but each computer's creating different routes on the invoices.
Mm-hmm.
So how does this thing work? Does it analyze every user, or is it just one user?
Can you see my screen well now?
Yes.
This is the starting layout of FMBench, where you actually set a filter, and here you decide which user sessions you actually want to analyze at the same time. And this was one of the first ideas behind it, because we currently have about 25 users in our company using our main system. And there are different kinds of users. Like salespeople use different features. Technicians use different features. When we work with the stock inventory, we use different parts of the system, and even we can even have remote users connecting through WAN, through VPN, and users connecting through on the local network. And sometimes we got a report from just a specific group of users that they have issues with speed, but all the other users are okay. So in this case, we can narrow the filter either by username or by privilege set or by the IP address or even environment, like only analyze sessions from from FileMaker Go, or only analyze sessions from Windows machines. And this way we can just focus on what's important for us. But we have all the data, and just by applying the filter, we decide how to visualize that. Actually, we even don't delete our logs at all. We keep them as a backup so that we can get back to them. So we have a track of one year of our activities in our system in the logs.
Hamza, you probably have millions of records for a given solution in that log table, don't you?
Yes.
Yes.
We
Yes, we do.
in our case the log grows. In our case, the log grows by about 1 gigabyte per 2 weeks.
Wow. Wow. That's a lot.
So Hans, it's just because a couple people were asking like little side conversations. So you get 3 files, but you really deploy 2 of them. One of them is the log file, which is, again, in most cases going to be on the server. And then there's this file, which hardly anybody runs other than admins or the developers. And who logs is driven by if you turned on logging at their session, which he said everybody. So it's run through. It's a plugin that's got to be on everybody's computer that's running it, and then the script steps have got to. Every script has got to have the logging turned on to it. Okay.
Yeah.
So it's not like 2 minutes to deploy, and again, it depends on how big the solution is and how many scripts you got and whatever kind of good stuff. But you notionally can get it done in a day or two. Just wrote through there, copy and paste the steps through the scripts. And then after that, it's available whoever's on that server.
Yeah. Well, the reason, because it takes some effort to actually implement it. That's why we, as a part of FMBench, have a custom function we call a debug level, and this custom function is used to turn this on or off completely from a single point. So you don't have to worry about leaving that in the solution forever, because you can just turn it off when you need it off and turn it on when you need it on. But as I said, in our solution, we have it constantly on, and the value we get from it is the troubleshooting ability, because it's just like with insurance. You don't know that you need it until you need it, and when you need it, it's too late to turn it on.
Does all this logging make things take longer?
Yes, a little bit, but we do even measure the overhead, and actually, the bottleneck finder has a mechanism to warn you that the overhead is significant for specific scripts. So, for example, if you have a script that does almost nothing, like it just sets a global variable or something, then you may consider not logging execution of that script, because the overhead would be significant.
Do you have any question? Do you look for specific things at all? Like, I found things littered through code, like somebody's putting like refresh window, flush all, join results, and that would run perfectly fast. But unfortunately, as that user then, as the screen refresh, slowed everybody else down.
Yeah. Well,
and it would have been hard to find, or deleting like a lot of records. It runs fast, but it slows everybody else down.
Yes. Well, there are things that are well known to be slow or fast, especially thanks to Mark Richman, who focuses on finding out how much different techniques require transferring data between server and client. But what I also discovered last year when I was preparing our demo for last DevCon for 2013 is that the same thing may be faster in one situation and slower in another situation depending on the conditions. So it's hard to say that the specific thing is always bad or always good. There are, of course, cases when it always makes sense, but you can be surprised by the fact that thing that you consider fast can actually be slow. I have 2 examples from last year. One is the position versus pattern count. If you want to find out whether a large string contains a substring, which function is faster in your opinion? Is it position or pattern count?
Position.
We all vote for position.
But I use pattern count almost exclusively.
Okay, you are almost right.
Yeah.
Almost.
Okay.
Because, of course, position can stop at the first occurrence and doesn't have to search through the whole string. But there is one and only one exception when position is actually slower than pattern count. Can you imagine what it is? Empty strings. Because position has 4 parameters and pattern count has 2 parameters. And there is overhead in passing a parameter to a function. So when you execute pattern count with empty parameters, it returns a little bit faster than position with empty parameters. Of course, this specific example doesn't have a practical use, but there is a case when position is slower than pattern count, and that's one example. Another example, which is much more practical, is using replace field contents or using set field in a loop. What do you think is faster if you want to replace, if you want to set thousands of records to a specific value?
Depends on how many fields you're setting.
That's true. That's absolutely
That's
true.
If you're
correct.
setting 4 or more fields, you should use a loop script. If you're doing 1, you should use replace.
Okay, I have a surprise for you.
Really?
FileMaker did a great job in speeding up the script engine. When I did the benchmark this in FileMaker 11, replace field contents was faster when I was only changing the value of a single field, and it was about the same fast when I was replacing value in 2 fields. When I tried it with FileMaker 12, and I think it was with more than 10,000 records, set field in a loop was faster than replace field contents even on a single field.
Does it depend on whether you put open record at the beginning and then a bunch of set fields, though? Like, I find that it used to at least make a big difference if you open the record and then set a bunch versus setting and then setting and setting and setting.
Yes, exactly. In FileMaker 11, the main difference was that in a loop you were using just one commit record per record, while replace field contents was committing every single field. But as I mentioned, in the 12 has so much faster scripting engine than 11 had, that loop with a set field for a single field is already in some cases faster than the replace field contents. And I can imagine the same being applied to other features of FileMaker. So if there is a technique that's better to use now, it doesn't mean that in the next version of FileMaker or the next one it will be still true. And it's very important to revise your decision based on the current situation. I hope you found this useful.
Yeah, really
Yes,
useful.
yes, thank you.
Yes.
And if you have any further questions, then feel free to contact me either by email or just call me, and I will be glad to help you. And as I mentioned, we have a lot of experience with both troubleshooting and optimization, so if you need help, just let me know and we can help.